Okay, question 15. Here is a speed time graph for a train. So speed time graph. So let's zoom in a little bit on that. So so looking at that, we've got what appears to be constant acceleration, constant speed, and then a decreasing acceleration. What does it say? Describe what is happening between 10 and 13 seconds. So that's between this point and this point. So we're going at a constant constant speed. So what is happening? It was a train, wasn't it? I keep dragging my finger and it coming out as a line. So what is happening between 10 and 13 seconds? Yeah, it is a train. So the train is traveling at a constant speed. Let's try it one more time. The train is traveling at a constant speed. Work out the distance travelled by the train in the first 13 seconds. So 13 seconds would take us to, let me grab my ruler. So we want to work out the area of that. We could treat it as a trapezium, or we could treat it as a triangle and a rectangle. I'm going to treat it as a trapezium though. So I'm going to say that the distance travelled of a speed time graph is the area under the graph. So I'm working at the area of this shape, and the area of the shape is a trapezium. So the distance is going to be equal to a half of the bottom length is 13, and the top length of the trapezium is, I believe, 3. 10 to 13 is 3. And we're timesing that by the height, which is 12. So it's going to be equal to 16 times by 6. I've just done that half there on the 12. So 16 times by 6 is going to be 96. So 96 meters. And then part C, work out an estimate for the acceleration of the train at time t equals 20. So we, as I said, we've got a decreasing. So, the acceleration is going to be equal to the gradient of the curve at that point. So at t is equal to 20, that will be there on the graph. So I'm going to try and take a tangent to the graph, or as close to a tangent as I can. So let's say I'm not quite happy with that. So what I'm going to do is I'm going to zoom in, try and get this as accurately as I can. And we can go even further than that. Right, so okay, so now let's zoom back out, hopefully. Right, so I want to work out the gradient of that curve. And there will be a band of error on this, but I'm going to go as accurately as I can. So the difference in y between there and there, it's not great because I've gone off the graph, but that's fine. So that top value there would have been 20 if we carried it on. So we're looking at 20 and 13, so the difference between 20 and 13. So the gradient of the curve is going to be equal to 20 minus 13 divided by, did I mean 13? Let's just double check while I'm up here. I did, and then we've travelled 25, so divided by 25. So I'm looking at, for mine, I'm looking at about 7 over 25. Which is going to be 0.28, I believe. So I'm going 0.28 for mine. and there'll be a band of error on there, so anything probably within about plus or minus 0.02 or 0.03 would be absolutely fine. Okay, question 16 then. M is inversely proportional to the cube root of n. So we're given a value and we're asked to find n. So inversely proportional, so m is inversely proportional to the cube root of n. So 1 over the cube root of n. So that's going to be that's my equation with the proportionality symbol. I'm going to say that is equal to m is equal to k over root cube root. It should have been cube root of n. So for my first values then, no, yeah, that's right. So if I put my first values in, so I've got 46 is equal to k over the cube root of 125, which is going to be 5. So k is going to be equal to 46 times by 5, which is going to give me 230. So my actual equation is going to be m is equal to 230 divided by the cube root of n. And then we're told find the value of m when n is equal to 8. Well, the cube root of 8 is going to be equal to 2. So 230 divided by 2, which is going to give me 115. We've got no units here, it's 115. Okay, question 17. So O is the centre of the circle. The line EF is the tangent to the circle at the point B. The line EF and GH are parallel. The angle ADC is 42. Work out the size of angle CBF. So C to B to F. So I'm trying to work out this angle here. CBF. Okay, my steps are going to be then. Right, so I'm going to start by saying that angle, I'm going to do it up here so I can write it next to. I'm going to say that angle ABC, so ABC will be equal to 42 degrees, and the reason is that angles from the same segment are equal, so that angle has to be equal to that angle. So angles from same chord or same segment equal. I'm then going to say, so I had to think about this for a while. If you imagine these, the parallel line here was actually starting exactly here, and then we gradually slid it down. 2 points on the circumference must create an isosceles triangle with the circumference. So if you imagine them there, as we gradually move the parallel line down, we would find that if we go into the circumference, we would constantly have an isosceles triangle. So that's got to be an isosceles triangle. So ABC, actually I should have said triangle. Triangle ABC must be isosceles. As lines are parallel. So based on that, I can say that that angle and that angle must be equal. So let's go for ACB must be equal to 180 minus 42 divided by 2. So that's going to give me 148 divided by 2, so that's going to be 148 divided by 2 is going to be 69. Let's just double check. 180 minus 42, So there we go. 138 divided by 2 is 69. And the reason is they're base angles of an isosceles. And then I can say that actually the angle that I'm after, which is CBF, must also be equal to 69, as it's an alternate angle. Okay, so there we go, 69 degrees. Have we got an answer line? Yeah, 69. Okay, question 20. Here is the graph of a circle. The circumference of the circle is 20 pi. Work out the equation of the circle. Okay, so the equation of the circle is, it has centre 0, 0, so it's going to be x squared plus y squared is going to be equal to the radius squared. So if we are told that the circumference is 20 pi, well, the circumference is equal to 2 pi r. So 20 pi is equal to 2 times pi times r. So cancel my pi's and divide by 2. So the radius is equal to 10. So the full equation of the circle is going to be x squared plus x squared plus y squared equals 10 squared, or equals 100. Part B, decide whether the point 78 lies inside or outside the circle. Okay, so we need to compare, well, we need to find what 7 squared plus 8 squared is. So 7 squared plus 8 squared is going to be equal to 49 plus 64. So that's going to be equal to 113, 113. Let's just double check. So 7 squared plus 8 squared is going to be equal to 113. So 113 is greater than 100. So the point 78 would be outside the circle. Okay, question 19. ABCD is a parallelogram. A to D is equal to vector A to B is equal to vector B. E is the point such that, D to E and E to C is 2 to 1. Okay, so BCF is a straight line such that BF is 3 halves of BC. Okay, work out the vector B to D. So B to D first of all, so we're going from here to here. So we describe that as minus B plus A. So minus B plus A. For the final one, prove that AEF is a straight line. So prove that AEF is a straight line. Okay, to do this, I'm going to try and work out A to E and A to F and show that one is a multiple of the other. So A to E is going to be equal to A to A plus if we look here, we've got it's going to be equal to 3 parts, so it's going to be 2/3 of D to C. So D to E is going to be equal to 2/3 of D to C. So D to C is B, so it's going to be plus 2/3 of B. Okay, and then if I look at A to F, so A to F, I've got a feeling I might have written that down wrong. No, that's right. So A to F, I'm going to describe A to F as A to B plus B to F. So A to B is just B plus B to F, or B to F is B to F is 1.5 or 1.5 B to C, so 1.5 or 3 over 2 times by A. So from that, what I'm going to do is I'm just going to write this the other way around. So 3 over 2 A plus B. And what I'm going to do is I'm going to try and take it out 3 over 2 as a common factor. Well, not as a common factor. So the reason, and then what would I need to times B by? I would need to times it by the reciprocal, so 3 over 2 B. So that's 3 over 2 times by AE. And I should have left myself a little bit more room to write, so I'm going to kind of follow up over here, which means AEF is a straight line. Let's make my writing slightly clearer. Line as both start at A. A and are a multiple. Okay, nice question. Okay, here's a graph of y is equal to sine x. On the grid, sketch the graph of y is equal to sine x minus 1. Well, minus 1 is going to bring every point on the graph 1 down. So if I kind of bring them all roughly 1 down. So that's going to be my general pattern. It's going to be the same looking curve, just translated 1 down. So as close as I can. There we go. Okay, here is the graph of cos x. Transformation is applied to y is equal to cos x. The new coordinate of the point after the transformation is 181. So 181. So we've moved up to there. Write down the 2 possible equations for the new graph. So we could have either reflected it in the in the x-axis. So we could have gone for a translation of minus cos. So y is equal to minus cos of x, or we could have translated it to upwards, which would have been a translation of let's change pen colour just because I'm scribbling over this equation. So plus 2 at the end. So it could have been y is equal to cos of x plus 2. Okay, question 21. Looks nice. Here is the diagram of a roof. The roof is made of 2 isosceles trapeziums and 2 isosceles triangles. Okay. The perpendicular height of ABC is 10% longer than the perpendicular height of x. Sorry, let me look at that again. The perpendicular height of triangle ABC is 10% longer than the perpendicular height of x. So that's x, so that height there must be x times by 1.1. Show that the length CF, so that length there, show that the length CF, so if I call that y for now, is equal to 10 minus 2 root 0.21, so that's plus 4. Okay, right. So let's start with the area of a trapezium. So the area of a trapezium is going to be equal to a half of y plus 10. I'm not sure whether that's going to help. So let's see. So I don't think the area of the trapezium is going to be overly helpful. I think that's quite deceptive. All I'm going to do is create a formula for the area in terms of y and x. I could, but I don't know what the area is. I could work out the area twice. That might work. That would work. I think there's a better way though. So if I work out y a different way, so if I say I wanted to work out this length here, let's call that, well, we'll cover that in a minute. And if I want to work out this length here, let's call it lowercase a for now. Then to do that, I need to work out this length here, and I can use Pythagoras to work that out. So I'm going to say that if we start with this one, and I want to work out the length AC, then I know that so let's get rid of that for now. So I know that AC is going to be equal to, well, that's going to be the hypotenuse, so it's going to be AC squared is going to equal 1.1 x squared plus half of that would be 2 squared. So that's going to be equal to 1.21 x squared plus 4. And I'm going to leave it like that for now, because in effect I'm going to square root and then square it, so I'm okay with that as it is at the moment. So my next bit is I want to work out a, so I'm going to say that a squared is going to be equal to AC squared minus x squared, so that's going to be equal to AC squared, which we've just worked out, 1.21 squared minus 1.21, I've kind of misspoken there, 1.21 x squared plus 4 minus x squared, so that's going to be equal to 0.21 x squared plus 4. So that's a squared. So if we kind of square root that, a is going to be equal to, I can see this working out now, 0.21 x squared plus 4. So if I want to work at the length, I called it y, but let's go CF, that's going to be equal to the full length of the bottom, 10, minus 2 lots of a. So that's going to be equal to 10 minus 2 lots of 0.21 x squared plus 4, which is what we were asked to show. So that works out okay. There we go. Okay, and that's the end of the paper. I was just about to say next question. That's the end of the paper. Nice paper, really nice paper. Very much enjoyed doing that. Some nice, really nice challenging questions. Needed some thought. I think I probably could have worked that one out the other way. In fact, I'm going to feel free to end the video now. I'm going to try this just with the second way, see whether I could have worked it out following my previous way. So let's just give that a go. So I'll change pen colour for this just to see if it works out. I'll probably end up getting frustrated with myself and giving up, but we'll see. So I'm going to say that the area of that trapezium would have been a half of AB, A plus B times by the height. So that would have been a half of 10 plus y times by x. And I'm going to say that the area of the shape could have also been found by looking at the area of the triangle. So that triangle, and I'm actually going to have to follow exactly the same process here, so it's not going to be any different particularly. Let's just say it then. So the area of the shape could have also been found by saying that it was 2 lots of A times x, so it would have been 2 lots of A plus, so in effect it's going to be 2 lots of AX plus 10 times x, and we said that that was that there, so that would have been, if you take x out as a common factor here, 2 lots of, actually we can take 2 out, so 2a times by a, which we said was square root of 0.21 x squared plus 4 plus 5, and if we put these two things equal, so a half of 10 plus y times by x would have been equal to 2x times by square root of 0.21 x squared plus 5. Right, so I could have said cancel my x's, and I've got my square root a little bit too, plus 4 square rooted plus 5, so 10 plus y would be equal to 4 lots of square root of 0.21 x squared plus 4 all squared plus 5. So that would have been, that would give me 20, and then subtract 10, so y would be equal to 10 lots. 10 minus 2 lots of the square root of 0.21 x squared plus 4. So that would have worked. Yeah, that would have worked. I think that was a slightly longer method though. But yeah, okay, nice question. Very thought-provoking. Overall, yeah, really great paper. Thank you very much for that third space learning. That was very enjoyable. Hope you found that useful. If you have any questions or comments, please feel free to add them. For targeted revision, I will make sure that I chapter this by the question, what the question was. So if you want to target your revision, you can pick that out from the kind of the chapters within the video. Thank you very much for your time. Good luck, and I will see you soon.